So today we're talking about solving simultaneous linear equations in two unknowns by the graphical method, or in the short form, solving linear equations by graphical methods. We have two different linear equations, x plus y equals 6 and x minus 2y equals 3. Every point on the graph of each equation is a solution of the equation. So each equation will have an infinite number of solutions. But are there any common solutions between them? Well, let's take a look. I'm going to start with a table. So first thing I'm going to do is look at three separate points. And then I'm going to see if the point is a solution of x plus y equals 6. And then if it's a point on this if the point is a solution of x minus 2y equals 3. So first with point A, if x equals 2 and y equals 4, I'm going to check 2 plus 4 equals 6. That is true. Now let me try that point over here. 2 minus 2 times 4. Does that equal 3? That does not. So point A is a solution of the first equation, but not the second. Now let me take a look at point B, 1 comma negative 1. 1 plus a negative 1 does not equal 6. However, if I plug in 1 and negative 1 for x and y, 1 minus 2 times a negative 1 ends up being 1 plus 2, which does equal 3. So point B is a solution for the second equation, but not the first. Let's take a look at the third point. 5 plus 1 equals 6. That is true. And how about 5 minus 2 times 1? 5 minus 2 times 1? 2 times 1 is 2. So we can see point C is a solution for both the first equation and the second equation. And if I were to go ahead and graph x plus y equals 6 and x minus 2y equals 3, I can see that common point here of positive 5 and positive 1 as my xy coordinates. So a system of two linear equations such as x plus y equals 6 and x minus 2y equals 3, as we saw over here in this activity, is called a simultaneous linear equation in two unknowns x and y. A solution of this system is a pair of values x and y. So my answer is going to be an xy coordinate. Don't forget that, super important. That satisfies both equations. So whatever this value is, it has to work for the two. Let's take a look at an example and we'll talk about steps at a time here. I could create a random table of numbers and eventually I'm sure I could find solutions to both the equations. However, what I'm going to do is solve these simultaneous equations graphically. So the first thing I'm going to do is work with the equation x plus y equals 1. I'm going to graph this using the x and y intercepts. How can I do that? Well, set x to 0. If x equals 0, y equals 1. So I know my first point is about right there. Now I'm going to set y equal to 0. Well, if y equals 0, then I have x plus 0 equals 1, so x equals 1. So then I have my next point here. I'm going to take a line from those 2 points, and I'm going to make sure it goes pretty far here. So let's see, this isn't going to be exact because I'm not at home using a ruler, but I'm going to go ahead and give it my best shot. It should go something like that. Okay. So now my next equation is 2x plus y equals negative 2. Well, if x equals 0, again using the y-intercepts, the x and y intercepts, if x equals 0, then y equals negative 2. So my first point is at 0 comma negative 2, which is about right there. Then if y equals 0, I'm left with 2x equals negative 2. So solving for x, I get x equals negative 1. So that's about right here. I'm going to take another line and connect those 2 points. And I see, let's just ignore that last spot over there. There we go. And I see that I have a point of intersection right over here. And it looks like that point of intersection is -3, comma 1, 2, 3, 4, +4. So, step 1, use the intercepts to graph. I did that. Step 2, find the common point. I did that. It's -3 and 4. Step 3, I want to test the point mathematically. Here's where a lot of us often forget. Here's a step that we often skip. But I'm going to go ahead and test these points out in both of my equations. So if this is my x and this is my y, I'm going to plug it into this first equation, x plus y equals 1. So then -3 plus 4 equals 1. That's true. Now I'm going to take a look at 2x plus y equals -2. So 2 times -3 plus 4 equals -2. Is that true? -6 plus 4 does equal -2. That is true. So graphically, I can see that -3, comma 4 is a solution of the simultaneous equations 2x plus y equals -2 and x plus y equals 1. Now there are some disadvantages to drawing things, to solving solutions graphically, and we can kind of see where those problems may lead. But here's a challenge for you to think about. What I want you to do is solve the simultaneous equations 3x plus 4y equals 12 and 6x plus 8y equals 9 graphically. You're in for a surprise.